Hi everyone, welcome to North Campus Calculus Problem Solutions. This is Chapter 1, Section 1 and Lecture 10, Trigonometric Functions. In this section, we will work with the sine function, and sine function is one of the most fundamental trigonometric functions. Do not forget to subscribe to the channel and leave a comment if you have any questions or suggestions. The sine function is defined for all real numbers, and it represents the y-coordinate here of a point on the unit circle. And for that reason, sine function will always have values between -1 and +1. And the domain of sine function, the sine function is defined for all real numbers because for every real angle, we can locate a corresponding point on the unit circle for the sine value. Therefore, sine x exists for every input, and the domain will be from -infinity to +infinity. For the range of the sine function, we have when a point moves around the unit circle. Let's see it here. Let's take this unit circle, and when a point moves around unit circle, its y-coordinate here, y-coordinate from +1 to -1, its y-coordinate never goes above +1 and below -1, since sine x represents this value between plus and -1. So the range will be from -1 to +1. For the key points of sine function is a periodic function with period 2 pi. This means that the graph repeats at every 2 pi radius, so it has a wave-like here, such as this wave-like oscillating pattern. Each complete wave looks identical here. Each wave looks identical, but its symmetry is with respect to the origin, not vertical axis. And sine x is an odd function. This means that sine of minus x will always be equal to minus sine x. This means that the graph of sine x is symmetric with respect to the origin. In other words, if you rotate the sine function 180 degrees around the origin, it looks exactly the same. It does not change. Sine x also oscillates between minus and plus 1, as I've shown you before. And our first example show that sine of alpha equals the sine of 180 degrees minus alpha, and sine of 180 degrees plus alpha equals the sine of minus alpha. Then I need to use the unit circle here, and this problem is really an important one for you to understand trigonometric functions, and this graph is important. And let's say draw this, and let me draw this. This is here, and we have a line here, and let's take this here. Okay, here we have alpha degrees. This means that here is alpha, here is also alpha. They are all identical, equal angles. Those are all alpha. If we have alpha here, we have here 180 degrees minus alpha. Why? Because here we have 180 degrees, and if we go to here alpha degrees, this is 180 degrees minus alpha, and here we have 180 degrees plus alpha, and for here we have 0 degrees here, and this is the negative direction, so here we have minus alpha. The sine value of alpha here will be, as you see here, that point. This is sine of alpha, and this point is also the sine of 180 degrees minus alpha. Then sine of alpha will be equal to sine of 180 degrees minus alpha. At here, as you see, this is minus alpha, and sine value of this will be here, and here we have sine of minus alpha, but also we have here 180 degrees plus alpha, and the sine value of this is here. This means that here we have sine of 180 degrees plus alpha, and they are equal. Example, find the values of sine x at the point x equals 0, pi over 2, pi, and 3 pi over 2. Again, we will draw the unit circle here. At unit circle, we have here 0 degrees. Here we have pi over 2. You have here pi, and here we have 3 pi over 2. And the sine value of 0 will be here, this point. And this means that sine of 0 is 0. The sine of pi over 2 we have here, and this we have plus 1 here. This means that sine of pi over 2 is equal to 1. And for the sine value of pi, we go here, and this point is the sine value of pi. This means that sine of pi equal to 0. And at this point, we have here minus 1. This means that sine of 3 pi over 2, sine of 3 pi over 2 is minus 1. Next question, find the value of sine 210 degrees. To solve such questions, you need to know some special triangles. For that question, we need to know this one. We have 30 degrees here and 60 degrees here. That's A, B, and C. If the hypotenuse is 1 centimeter here, this means that at the opposite side of 30 degrees, we have 1 over 2, and we have here square root of 3 over 2. This means that sine of 30 degrees is 1 over 2. Sine of 30 degrees is the opposite side of it. And sine of 60 degrees, the opposite side here, sine of 60 degrees is square root of 3 over 2. You need to know this triangle because you will always use in trigonometry this function, this triangle, always. And in order to find 210 degrees, sine of 210 degrees, we need to use again unit circle. And we have here 0 degrees, we have here 180 degrees, and for 210 degrees we need to go here in this direction plus 30 degrees. Let's go here, and this angle is 30 degrees, and we have here 210 degrees. And now we need to find the sine of this, and then we draw this triangle. Here we have 60 degrees, and since hypotenuse is here 1, and from this triangle the opposite sides should be 1 over 2. This means that we have here 1 over 2. For the sine value of 210 degrees, sine value of this angle is here. Then here we have sine of 210 degrees equal to minus 1 over 2, because sine value at here is negative, less than 0. Find the value of sine of minus pi over 4. Pi over 4 is 180 degrees over 4 and equal to 45 degrees. So we need to know another triangle here, equilateral triangle. This is 45 degrees and this is also 45 degrees. You need to know this triangle, okay? Let's say A, B, and C. If we have 1 here, the other sides should be 1 over square root of 2, 1 over square root of 2. This means that sine of 45 degrees or sine of pi over 4 is 1 over square root of 2. Sine of 45 degrees is 1 over square root of 2. Also cosine of 45 degrees is again 1 over square root of 2. But for this question we don't need it yet. Okay, let's draw the unit circle. In order to not memorize something, you should always use the unit circle. We should have minus pi over 4. Because the angle is negative, we need to go a negative direction. And let's take here, we have here 45 degrees, and we have here minus 45 or minus pi over 4 radians. And we need to draw the triangle here. Radius is 1, so we have here 1, and a sine of 45 was 1 over square root of 2. So this line, this length of here will be 1 over square root of 2. And we need to find sine of minus pi over 4. Sine value of minus pi over 4 is here. And this value is between minus 1 and 0, or it has a minus sign. Then sine of minus pi over 4 will be minus 1 over square root of 2. And this was the last example, and see you later.